Well, welcome to recording 1A in a series on factoring quadratic equations. All you good people out there, we're in Unit 4, Chapter 4, Quadratic Equations for Mathematics 2200. And we're going to focus on review of factoring techniques from Mathematics 1201, kind of to help you remember some things you need to know for the rest of this section of the textbook. What does it mean to factor a polynomial? Pause and think about that for a moment. When we think about a number like, let's say 10. To factor it into two other numbers, such as 2 and 5, that means that 2 times 5 must give us 10. That's why they are factors. So, the similar idea applies with polynomials. Let's use these two examples. In this first case, if I distribute the 2x times both terms, I will get 2x times 2x is 4x squared plus 2x times 1 is 2x. So the original portions here, the 2x and the 2x plus 1, those are the factors. So this is the factored form, and this is the expanded form. Likewise, we do if you recall a bit of FOIL or a game box method or whatever you did for the second example here, like so. And I've used Benny binomial, as I've called it. And x times 2x gives me the 2x squared. And 10 times 1 gives me the 10. And then by multiplying the last term by the first term, and this first term by this last term, we'll get a total of 21x. So the expanded form here is 2x squared plus 21x plus 10. One of the keys with the factors is to recognize that the first terms in each bracket will give me the first term in the expanded form, and the last two terms, when I multiply them, will give me the last term in the expansion. So that's a key to help us understand some factoring. Therefore, applying some thinking to this next one, we have two factors we want to make. The first term is x squared, so we need to have an x and an x at the beginning of the brackets. The last term is a positive 6. So what numbers could we choose to make positive 6? So I could try the 1 and the 6, but there's going to be a problem because I need these terms to give me the right total for the middle one. 1x and 6x, that's going to give me 7x. So this is not the correct factoring that I need. If I try using a negative 6 and a positive 1, I will get, yes, negative 5x for that middle term, and I'll get an x squared for the first one. But I needed a positive 6 for the last term, so this is not correct either. Now, for this last attempt, x times x is x squared, and negative 2 times negative 3 is positive 6. That's good. Negative 2x here, and negative 3x here. So it does indeed give me the correct expanded form, because I've got negative 2x, negative 3x is negative 5x for the middle term as needed. So the expanded form is correct there. The factored form is x minus 2, x minus 3. And we're done. Let's go to this form. Now, a common mistake is for many students to think there should be automatically an x and an x at the beginning of the brackets. But let's look carefully. We've got a 3x squared there. So I should have a 3x and an x at the beginnings of the brackets. That way I'll get the correct first term. Now I need a negative 4 for the last term. And they will indeed give me the negative 4 that I need if I use negative 1 and positive 4. And I will get 3x squared here. But now we've got to check. Negative 1x plus 12x is going to be not going to be negative 4x. However, if we use 3x plus 2 and x minus 2, we'll have the correct factors. simply because we get the correct first and last terms, and these two terms from the middle give us the correct total for the middle. For this next type, the difference of two perfect squares, you may recall you take the square root of each term. So you have an x, and then the square root of 9y squared is 3y, so we have a 3y and a 3y, but one has to be minus, one has to be plus. Now if we check that, check the multiplication, x times x is x squared, negative 3y times 3y is negative 9y squared. We need to have no term in the middle, and indeed that's what happens. Negative 3xy here and positive 3xy here add to give 0. So they'll just cancel each other out. Next we look at 4x squared minus 16y squared. There's a common factor there of 4 first. Always look for a common factor first. And in this case it's a 4, and then we can factor the brackets, the x squared minus 4y squared. That's still a difference of two perfect squares. So we get x minus 2y, x plus 2y. In this next one, I'll take out a common factor first, and then I factor what remains in here. And I get 2x plus 3 times x minus 2. You should check the expansion of that using FOIL or whatever method you use. To conclude, trinomials of the form ax squared plus bx plus c can be factored by considering the factors of the first term and the last term, then test for correct factoring by expanding the product of the binomials. And a difference of two perfect squares has factors of the form a plus b, a minus b, which, by the way, are conjugates. That's a term I'm introducing here. Didn't introduce it earlier, but they're conjugate factors. One is plus in the middle, the other one is minus.